Hey guys, and we're back for more rational graphing today. So I have to talk really fast to make sure that I make it through everything to explain the RATEY method for you. These problems, notice, are a little bit different than the ones we did in the last session because we could have a variable in the top. We could also have a much larger polynomial in the bottom, and there's rarely a number added on the end. So when functions look different than what they looked like before, we're going to want to use the RATEY method. The RATEY method will work with the others if you get a common denominator and add the two together first, okay? But first, the R. The R stands for the roots, and we know roots of a graph are where it crosses the x-axis. We're going to find the roots by taking the numerator, and setting the numerator, the top, equal to 0. So our top of our equation is an x. We're going to take x and we're going to set it equal to 0. There's no work to do, so we know that at x equals 0 there is a root, which means it crosses there, or that is a coordinate, and we want to write a coordinate as such, 0, 0. If our x value is 0, we already know the y value is 0. So 0, 0. So we're going to put a dot there. And all of our graphing is going to be just estimates. They're not exact, so you don't have to have a perfect graph, and you don't need lines because we're not looking for perfectness here, okay? So I'm going to change colors, and everything that I do for the A will be in purple, and A stands for our vertical asymptote. So we'll just say vertical asymptote. You could just say VA if you wanted to. Remember, the vertical asymptote is where the denominator equals 0. So we're going to take the bottom and we're going to set it equal to 0. So our denominator being x plus 3, we're going to set x plus 3 equal to 0. When we solve and subtract our 3 over, we get x is equal to negative 3. Now for an asymptote, remember that is an equation, so we just want the equation. You don't have to write that as a coordinate. The other one, we wrote it as a coordinate because it was a point. A root is a point. A asymptote is not. So we want to go about where negative 3 might live, and we could say here. And we're going to draw that vertical asymptote, and we want to make sure that we name it. Because remember, we don't have any tick marks. You don't have to draw them. You just put where you think it would live, Rob Ross style, and just label it. Okay? Now, our T, I'll do our T in pink. Our T stands for tangent or together. Now, what we're looking for is perfect squares in either the numerator or the denominator. So you're looking for something like to have this x plus 3 in parentheses being squared. So we're looking for perfect squares. In this case, we don't have any, so we're simply going to write none. If you did, if they were in the denominator, meaning together, that means, remember how our graphs before the other day, they looked like this, and the branches went in opposite directions? If they're squared on the bottom and they're together, that means that they're going to go in the same direction there. So if one goes up, the other one must go up also, okay? But in this case, that doesn't happen, so we don't have to worry about that, okay? Now, our E. I'll do our E in blue. E stands for our end behavior. End behavior, meaning what's happening at the ends. Where's the graph going as our x values get large and as our y values get large? So we're going to look for which degree is larger. Now, when we talk about degree, remember we're talking about the exponents of our polynomial. Your largest degree would be your largest exponent. So we have a little acronym that helps us to remember what we're going to do depending on the degree of the polynomial. And our little acronym is BOBO, BOTN, BOTN, eats, RC. Now you don't have to write this out for everyone. This is just so you have it in our first example. BOBO means big on bottom, 0. BOBO, big on bottom, 0. So that means our horizontal asymptote will be y equals 0. So you might want to make a note to yourself here. This is the horizontal asymptote, y equals 0. Big on top, BOTN. Big on top, none. None. Big on top, none. There is no horizontal asymptotes. And we will have some of those, and you'll be able to see what that looks like. Eats RC means everything, means exponents are the same, the ratio of the coefficients. So if you notice, my degree on the top here, my degree is 1 because my exponent is 1. Here, my exponent is also 1, so my degree is 1. When my degrees are the same, I want the leading coefficients. Well, the leading coefficient here is 1, and the leading coefficient here is 1 because there's no numbers in front. So eats RC means it's going to be y equals, and we take the ratio or the fraction of those coefficients, 1 over 1, which is just y equals 1. Okay, so we're going to go to our y. We're going to draw us an asymptote where we think 1 might live, and we're going to label it y equals 1. So that's going to tell us as our x values go really, really big, what's happening, as they go really, really small, what's happening. Now, the last thing we have to do is our y, which y is the easiest one to do. Y is exactly what you think it is. Y is your y-intercept. For y-intercept, we're going to plug 0 in for all of our x values. So we're going to take our equation as is, y equals, and we're going to plug a 0 everywhere we see an x. 0 plus 3. So that gives me 0 over 0 plus 3 is 3. 0 over 3 is just 0. So therefore, if my y value is 0, my x value was also 0, because remember I plugged it in, and a y-intercept is a coordinate, and it's 0, 0. So notice I have boxed in everything that I expected to see graphed, and we're going to plot 0, 0. Sometimes your root coordinate and your y-intercept are the same, and that's okay. That's great. It's just 1 point. Okay? So I have my red coordinate. I have my purple vertical asymptote. I don't have anything pink because I don't have any togetherness. My end behavior horizontal asymptote, y equals. I have it in blue, and I have my y-intercept in green. Now, when I get ready to graph, I'm going to graph it in orange. So 1 point we know it has to go through is this y-intercept. We also know that these asymptotes are things they really can't cross. Now, vertically, no crossing. Horizontally, sometimes it can cross, sometimes it doesn't cross. It only crosses if your root and your horizontal asymptote cross over each other. If your vertical asymptote has a root also, then we have what we call a hole. And if we have an example of that later, you'll be able to see what that looks like. Doesn't happen very often, but most of the time that's when you have a vertical asymptote and a root the same. Horizontal asymptote, root the same, then it can cross over that horizontal asymptote. So think of these asymptotes as like a fence, and think about how a dog runs around a fence. If you've ever seen a dog inside a fence chasing the cars as they drive by, they run along the fence, right? So you can think of if the car goes by, the dog is going to run along the fence this way. Now, if the cars were going this way down the street, the dog's not going to run into the corner, because even if the car goes around the corner, it's not going to run into the corner and follow the car. It's going to see it. There's a fence there. Can't go anywhere there. The dog's been there before, so it knows it's going to have to go down. And so it just sort of makes that path, and it never actually goes into the corner. So it'll give you your good branch down here in the bottom in your, what we could call the fourth quadrant, but it's in the bottom right-hand side of your asymptotes. Now we know we do not have any togetherness, which means if we go down on the right-hand side of the purple asymptote, we're going to have to go up on the left-hand side. So if I'm going up here, that means it's going to go down looking like this. We're not exactly worried about how beautiful your branches are. The important part is, are you going through the right points, and are your asymptotes at the right spot, and do you have your graphs drawn in the right places? How beautiful is what's important? It's just a sketch, okay? So I will not have enough time to finish another whole problem for this, but I will do another video of another problem for your day 2. So if you want to come back and see another one, you certainly may. But this will get you a good start on what you're looking for. There's also on in your folder on Google Classroom, there should be another page that's listed that says RATEY Notes. The one that says RATEY Notes has a sheet that looks like this. Okay, and it gives you all the explanations of everything that I just went through with you, so you can see that. And in case you forgot everything, or in case you didn't get everything written down, or you're like, oh, she said this, but I didn't write that down and I didn't remember it. So you can always refer back to that page, okay? So you will have a handwritten assignment on this. You're only going to be doing some of the problems, though. I think you only do the first 3 or 4 problems. You'll do the first 4 problems for this assignment, and then I'll do another set of notes and you'll do the next 4 problems. Okay? So y'all have a great day. If you have any questions, jump on one of our Hangouts. Y'all have a good day. Bye-bye.